Hi, everybody. We are here today to talk about developers and DevOps. Maybe Docker orchestration. No, yeah, we are going to talk about it. This talk is organized like in agile way. I don't know what does it mean, but I have a lot of things to say, and let's see where we arrive together. If you have a question, show your hand. And this talk is for all developers that maybe already knows what Docker is, and maybe already run Docker, or maybe you already use Docker in development. How many of you already use Docker or know what Docker is or ever execute Docker run? Okay, so that's great. So it's like a gentle introduction to Docker. Who am I? I'm Giulio, proud member of Pogroma, and with Giorgio, we created the Golang community, and there's a pretty big news. I live in Rome, I said, and there's a person that copied my avatar, the Pope. Yeah. So let's start together. So it's 2016. Docker is everywhere. Docker is in workshops, conferences, on startup sites. Docker as company got billions of found. Docker is into the Google App Engine. Docker is everywhere. Oh my God. So, can you read the title? More devs on DevOps. On the last conference, Fullo told me that I wronged the color and the slide. So, can you read the title? Okay. So, the title, this one. So, all the things you have to know in order to use Docker with orchestration in production like I did. But not really like I did, because we cried a lot. So please don't cry. And I hope your life will be more enjoying. And that's why I did this talk. So we are going to cut through some disillusion that there's around Docker, the Docker ecosystem. And is organized this talk about things to know. And I have 1,000 things to say. And so let's start with the first things to say, and Docker and container. Okay, the Docker ecosystem developed hard to push their technology. But this technology already exists. So the first thing to say is that Docker is not container, because the container technology has been invented and sponsorized by IBM and Google and Ubuntu. So what Docker did? Docker pushed a lot of marketing. Yeah, because they are really good on marketing. But that's not the real value. The real value of Docker is that they added a great API in order to simplify the developer's life. That's the real value of Docker. But Docker is not container. It's not strictly container. This technology started in 2002, the container technology. And Docker did not sponsorize the patches on the kernel at the beginning. So the first thing to say is that Docker did invent this technology, but they added a great value and marketing as well, but it's good. Second thing to say, virtualization is not container. A few months ago, I held a workshop about Docker, and a friend of mine told me, oh yeah, Docker, I know the virtualization thing. Yes, it's virtualization thing, but it's not really the virtualization, because have you ever seen this image? How many of you already saw this image? This image is everywhere, because if you start reading the documentation, there's this image, because you can see rapidly which is the differences between virtual machine and container. The real difference is that the container technology uses syscall to use and to isolate processes. There's really a huge difference with hypervisor technology that you have to install another operating system. So it was the 2012 Glauber Costa at LinuxCon in Europe say don't you think that the virtualization thing is a smell of operating system? Don't you think that virtualization thing is something that show the incompetencies of operating system? They show incompetencies of kernel, the Linux kernel. Because before the hypervisor technology, if I want to isolate a process, I had to buy another server. So hypervisor plays this great feature. And also say about container. Yeah, we have this other technology called container, but it will not be released soon. It was 2012. In 2013, Docker released its open source version. So I think that virtualization and container are totally different. I hope that you understand this, and because the real difference is that container use syscall, just with different flags on kernel, but it's very fast. That's the goal. As I said, it's all about virtualization, isolation. It's not virtualization. Because if I want to limit those attacks, those are two different attacks. The first one on file system are really easy to do. The first one, just fill the file system in few seconds. The second is the famous fork bomb. I think everybody, just for fun, tried it. And he filled the memory in few seconds. So container is about something that is going to isolate processes. That's the real value of container. That's the real value of Docker. The differences, there's another difference with virtual machine that you can install like Windows on Ubuntu with hypervisor technology. But on real server, on the network, this is not a killer feature. It's nice to have. But the real value of Docker and container is the isolation, and they provide a great isolation. What's DevOps? Have you ever think about DevOps? What DevOps means? What DevOps is? So, DevOps is the way to propagate error in an automatic way. That's DevOps. So DevOps, is DevOps a culture? Maybe. Job title? Maybe as well. Is a way of organizing? Yeah, way of thinking, yeah. But it's a movement. DevOps is a movement, and we shouldn't, and maybe we should talk about the common themes that DevOps is about, instead of finding a definition. And this talk is about developers that want to join the easy, in the easy world that is DevOps. And in order to do this, we have to know how DevOps started, because it was 2009, and comes a perfect storm. There was agile movements, there was lean methodologies, theory of constraints, and in management team. So everybody were talking about continuous flow against the waterfall. But they was excluding the deploy. They was excluding how the value arrived to the customers. So that's why DevOps started. It was 2009. So what DevOps does? DevOps, in the DevOps environment, they want to join two different teams. The developer teams that had the entropy, and they know object-oriented, yeah, with the operation teams. What it does? They want to stop entropy. They want to give stability, happiness, satisfaction. So there was a fight. DevOps explicit that it's better to collaborate with those two teams instead of fighting. Ta-da! This is a good paper that I invite you to read. It's the three-way DevOps, and I'm going to talk here briefly, but in order to start with DevOps, you have to know this. Three-way DevOps is, there are 3 rules about DevOps. I'm going to talk only about the first one, because it's the best one. What does it say? The first rule is about the lead time. I think you already heard this term. Lead time is an arrow from the idea to the money, from the idea to the business to the deploy. So DevOps, there's a lot of DevOps here. Lead time is the time that goes from the marketing head idea to the idea is developed. So when the first customer click on purchase, that's the lead time. And what we want that this lead time is shortened as possible. We want that this lead time is shorter. We don't want to make money in 2 years. We want to make money tomorrow. So we want to work on 3 variables. First variables is velocity. Velocity means that this lead time must be short. Variation means that all the manually things must be avoided. So variation is the differences. So we want that all the flow is without interruption, is without differences. The third one is visualization. Visualization means I need to know what's happening because I can recover soon. So those 3 variables are really important in DevOps way and in the 3-way DevOps. So it's really short and sum of all these methodologies. If you have questions, do you have questions? Are you okay with it? Okay. Are you sleeping? Okay. Okay, so we know that it's very important to increase velocity, reduce variation, visualize things. What we do? So we have this infrastructure. Me as web developer, I use GitHub, for example, in order to merge code. I can roll back code from feature. I tag releases, and I test my code. Also with TDD. I don't know if you use it. So DevOps say, but can you use the same tools, the same feature, like merging, release, rollback, of your web application, for example, to the infrastructure? Would be great if you start using infrastructure like a managed application. So imagine that you can divide the infrastructure from your web application and start merging, sharing, testing the infrastructure. Would be great. And that's where Docker won, because Docker provides files. You can share infrastructure. You can share the Docker file, Docker Compose. So this is a great adding value for the developer. So you can reproduce, share the files, use the force. What does it mean? 1 process per container. The real difference between the Linux container X is the container before Docker, and Docker is that Docker promotes the 1 process per container. For example, in a web application, you should have Nginx. In a tutorial, for example, you should have web application database and maybe cache. But that web should be like Nginx container, PHP FPM container, command line interface container, data container. So we are things getting complex very easily. But this is the Docker way. So you should use the Docker way. Use the force, use the Docker way. Because all the ecosystem is working, thinking that that container is just 1 process. So maybe the login system will think that that container is just 1 process. So if you have to push logging, you will have problems if you have multiple processes into 1 container. So it's not really have to, but it's a good practice. In the ecosystem, somebody says that if you are migrate your infrastructure from your legacy system to Docker, maybe you can avoid this rule. You can put more processes into 1 container, but it should be temporary, because that time you should use in order to get to Docker. Log2 standard, error, and output. As I say, Docker wants that you run 1 process in 1 container. So and how, for example, Nginx did in order to solve this problem. Those two lines are how the Docker file in Nginx in production. Oh, sorry, I didn't thought that is to. How Nginx solved this problem. So the goal here is to log to standard output the log and standard error their error. So easy rule, because one container is one process. A container is a box, isolated box for one daemon, for example, Nginx. How Nginx solved this legacy problem? They just create a symbolic link with the standard output and standard error with their legacy file. Other things to know. Can touch this. So, immutability. We saw that variation are very important. So we have to reduce variation. So it would be great to have this container that maybe you already tested, so you know that it works, goes to production, and maybe they don't have state. So don't modify container. If you start a container, don't edit config file. It's a bad practice, because containers are fast to deploy and fast to go live. So if you have to update a container, don't enter with SSH. Create another container, test it. Immutability is very important, because you reduce variation. And with container, if you change the container and you have multiple containers, containers are great to scale because they are immutable, so we'll have complicated things if you change. Environment. Variable, all the things. It's not a Docker thing, but it started with cloud. All the parameters are in the environment. And so it's quite tricky, not difficult, but you have to do something with PHP FPM. All the tips, I put all the tips on the bottom. This is a great idea for the next talk. Yeah. And how to do it? Just enable the, just say to PHP FPM, for example, to not clear the environment variable, because Docker is already isolated, so you don't need to clear the environment variables. And use the environment as parameters, as Docker suggests. Communication. Containers communication is very easy if you are on development. Containers communication are easy. If you have two containers, Docker modify for you the edge host, modify for you the DNS. So if you have Nginx and another container, you can ping Nginx if you are on the same node, because Docker daemon modify the host and resolve the IP and the name, as I said, if you are on the same node. Real world example, services. As I said, we have our backend, is in the bottom. You have database and caches. So in the Docker world, you should have Nginx service, the PHP FPM service, and Nginx must communicate with PHP FPM, that must communicate with cache, that have to communicate with database. And then you have this data. In container, it's good practice to use data as container. It's a data-only container. This is a good practice. And you will have few problems if you do it, but let's see maybe together, after, sorry. And maybe you have to add another services, PHP CLI, that is the command in order to run cron. How many is familiar with this? Okay. But those are services. What's the differences between services and containers? I mean, services is a group of containers with the same image. Yeah, maybe. And so you can scale, for example, Nginx. I lost the focus. Okay, so things get fairly easy. And so you can scale those services. And maybe you want 4 Nginx and 3 PHP FPM and just one command line interface, because cron, you don't need pushes a lot of effort on cron, maybe. And all of these have to to be connected with cache database and data. And as well, Nginx must know where phpFPM is. And if you run multiple containers on the same server, you have to say to Nginx to expose a random port, because or they will collapse soon. So you will have to place a load balancer that acts as reverse proxy and knows where Nginx are. So things are tricky. But think about multiple nodes. If you have multiple nodes, there are some rules. For example, data must be in each node. The other, I want that they spreadly, randomly push it in random node. Node are, for example, Amazon instances or Digital Ocean. So things get very tricky, very difficult to do this. And subnet with Docker is very easy subnetting. So maybe you want to say that the Docker Nginx must communicate only with phpFPM, and maybe you want to expose Nginx as a subnet from the load balancer. So you can start subnetting, but you have to say that phpFPM must communicate with cache, with data, with command line, and this is a mess. This is really a mess. But we are talking about only one microservices. One microservice. Imagine that you have multiple microservices. Do you recognize this? So, continuous communication is not for human. Ta-da! We need a tool that helps us to orchestrate and handle all of this and automate. So the next things to say is talking about orchestration. Orchestration and automation. So the things to know is that orchestration is not automation. Orchestration is about processes. Automation is about task, is a lower level. So you have to know what your processes are in order to have the best orchestration framework. What we have in the ecosystem, we have the orchestration that are developing now. We have the Kubernetes, Docker Cloud. We have a lot of orchestration. And Kubernetes, for example, is pretty solid. Docker Cloud is maybe for small startups. And you can use mesos, and you can create if you are crazy, maybe you are crazy, and you want to create with bashes and using Docker Swarm, Docker Machine, or that things that. How many of you use Docker in production? Okay, I don't think you use Docker Swarm, I think. I think you use an orchestration tool developed by one of the bigger. So this talk is cloud agnostic. I'm not going to here to show how is the best one for your company, because as I said, orchestration is about processes. But let's dream for a moment. Demo time. Who is happy for the demo time? Okay. So imagine that you are a developer. If I found the mouse, I can show you. Or at the bottom. So it's really 1 second, sorry. I'm going to find my mouse. Okay. That's a great idea, Cirpo. No, I didn't click it. Okay. So imagine that, good idea, Cirpo. So imagine that you are a developer. So you just created a great feature. And what you're going to do, you want to push this new feature. There's a little delay project. phpDay orchestration, okay. So imagine that you have just committed a great feature, and then you execute git push. There's a big delay. 1 second. Git push origin feature 1. Imagine this. Let's dream for a moment. How would be great to have an orchestration like this? 1 second. So Something is broke. No, no, sta andando. Sorry, one second. I run again because. Okay. So what's happening here? It just tests are running, and it's pushing. Okay, it's pushing my feature, or you already see that are running 9,000 tests and automatically. And what's happening in the button always? And in 10 seconds, 9,000. It's a dream. 9,000 tests are completed in 10 seconds and automatically goes to production. And because and it's fully deployed. And show you here the lead time. This is a dream because customer are happy. And this is great. This is the perfect orchestration. What's happening next? It's something that things get like complex because you enter in matrix and that's your personal matrix. So if I found like the mouse again, so it's happening is, are you in Skynet? So the things here, DevOps, the last human action happens when you commit. This is a good practice on DevOps. Really? Depends on your company, because we say that the perfect orchestration is about processes. You know what processes are, but you also know that a continuous delivery, continuous integration, reduce variation, and this is better, but it depends from your company to company. So let's talk about processes. What standard processes are? We know that we have to code, we have to run tests with continuous integration, and we need to deploy easily, but not with Docker. With Docker, we have to add multiple steps on this because something crashed. Weird. Sorry, I go back again. Something happened. OK, this is a great slide. Sorry, it crashes. But he jumped one slide. OK, let's start from here. So our process, my pipeline, is that I code. There's a building process that create container for me, and then test container and run test on my web application. Then he has to push to registry, because as you already know, Docker, in order to pull Docker, you have to push in a private or public registry, like Docker Hub. But there's someone or something that have to choose the right nodes, the right machines, where to push those nodes. So this machine choose node, pick the correct nodes, pull container, run blue-green. How many of you already know blue-green deployments? OK. Yesterday, Rasmus talked about that you did a bad deployment with Symlink. And he proposed a module for Apache in order to provide a bad deploy. I go back, sorry, because the slide was kind of broke. And, oh, it's still broke? OK. And there's another way to do this. Imagine that you have to deploy a new feature called the green feature. So what you do is that you raise those container, you create the container, you start container, you push on container great variables, as you say, as you saw. And so you have the new feature called the blue-green. You have new isolated process with the new feature. So you just say to the load balancer, hey, load balancer, start draining the blue container. So stop new requests. Very good. And stop new requests and drain it. And start slowly give to the new green feature, the call it green Nginx server, the new request. This is the blue-green deployment. You are distracting me. And so this is the best way. You are not going to lose connection. You are not going to lose requests. And you have, how to say in a polite way, you Yeah. So sim linking and modules are not necessary because you are creating a new Nginx. You don't need symlink. Maybe someone is doing bad deployment. Okay, so continue with the pipeline. And so we deploy, we start the green because it is the new feature, but we also need to say to the registration service, so we need someone that knows where containers are, because load balancer need to ask to someone where the containers are, and if those containers are healthy. So when a new container starts, need to say to someone that that container exists, is new. How to do it? Let's go further. How to do it? To the container registry and service discovery. This talk, as I said, is cloud agnostic, is organized like, I don't know when I'm going to finish, but is also opinionated. I think that the ecosystem pick Consul as the best service discovery and service registry. What's Consul? Is an open source project that really enter among the other service discovery. There was like HD, Zookeeper. So he entered like the last one, but he won for different killer features. The first of all is the simplicity. You can start a console just with Docker run console, exposing the ports. It's very easy to use. What's console is a key value store, so you can store any kind of value in it. And it's pretty developed for the high availability. So you can start multiple console, and they started connecting each other easily. And it has failure detection and health check for containers. And it works as service discovery because it lets you to say to him, hey, there's a new container. So it waits and also watch for healthy container. So load balancer, so let's go to here. So when a new container starts, must say to this container registry that there's a new container on production, and then you can run integration test on it, because integration test means that you create the green feature. Maybe you can test with a curl the new container very easily, and you have to configure the proxy, the balancer with the color. How? There's a lot of integration between console and Nginx and console and HA proxy. For example, HA proxy can be reloaded, and Nginx can be reloaded, or with a signal can be reload the configuration modified by the console template that is inside console. So that's the pipeline. That's my pipeline. I think you may have another pipeline, but this is pretty standard, and your customers are happy, and everybody are happy. So there's another way to do development. It has like 1,000 names. For example, graceful deployment, etc. Okay. How it works? If the green-blue deployment is like a button, push the green. You can see this as a slider because you can slowly add a new feature, really slowly, and maybe you can increase the number of containers with the new feature. Why? Because you can also roll back easily. You can roll back and recreate those containers and just start, not recreate. So this is another way of deployment. Pick your best for your company. Next thing to say is that you'll need a lot of disk space. Docker doesn't have a garbage collector, and each container are immutable, but they work on volumes. I think you are pretty familiar with this, but you will not have a garbage collector. Nobody will delete your, oops. That's why you're doing here, in this way. Okay. So nobody will delete volumes for you. So when you are going to create nodes on Amazon, for example, think about the disk space. Create the biggest as you can, or create very often. Oh, this is pretty annoying. Okay, resources. There's funny things with some orchestration tool. If you image this slide, is great. And there are some orchestration tool that if you run 3 containers on the same node, he'd divide equally the RAM. And this is pretty bad, because if you have a web application, you want that all the RAM is for the container for the web application, not for the command line interface that maybe you are going to use 1 per hour. So you can force and explicitly say that maybe the command line interface don't share equally. Just say command interface give just 1 GB of RAM and that's it, or percentage, like smaller percentage of maybe for the command line interface. There's a good tips. It's crashing. Imagine that you have 2 services. Each of those has different containers, services A and services B. How do you talk with another services, another container? How do you know where is the other container? For example, you have 3 container B and you are on the first container service A. You have to know one of those. You don't care which one, but you need one of those. So you have to place a load balancer on top of it. Are you okay with it? So you need a load balancer that knows where other containers are. Or you use DNS SRV. How many of you is familiar with this? DNS SRV? 1%. So what is it? Which is the oldest protocol that transforms names to IP? Is DNS. What we need here, we need to know where service B is. So DNS, why I didn't talk about it before? But there's a problem, because on different containers on the same host has different ports. So that's the problem. DNS doesn't say the port. But what DNS SRV does, this protocol also, if you query it, that's great. If you query it, it shows you that where are those containers named, for example, bash server. I don't know if you ever start a bash server, but and so this protocol is great for this. Always reply to you with where the container is and which port is exposing that container. Because as we said, we have to randomly assign port to same services on the same node. For example, if you start 2 Nginx, you have to say to Nginx start with a randomly port. So something happened here. Okay, how to do it in PHP? Very easy. PHP has this DNS get record. So just query to console or to the service registry that you have. But few service registry provide this feature. So this is one of the killer feature of console that provides this DNS server that already but already provide also a small and stupid load balancer, because it always provides a result on where containers are of that services, and console order for you those containers. So if you have service that has to call another service, this is maybe a good way, just using console. So query console, which is the container here, and then you can ping or use it as API. Use a log handler. Why? Because we say that variation is important, velocity is important, but also visualization is very important. So use a log handler, visualize things. Docker push a lot of effort in order to integrate all these drivers for logging. So you will have a daemon, like Nginx daemon, that write to the standard error and standard output, and those driver will automatically push to your log handler, like Helk, the Helk stack. I don't know if you ever heard about it. And this is the way to do it, DevOps. You have to see what's happening. Logging, you can group logs, divide error from logs. Then, fast is better. Okay, we are at 20, we have 100 of these slides. So we have 100 things to know, and we are at the 20th. So fast is better, always. Why? Because we are going to have multiple containers, a lot of containers. So a few times ago, Alpine replaced Ubuntu as standard image. Why? Because Alpine is 5 megabytes and Ubuntu was 60 megabytes. So when you deploy, when you build a container, 5 megabytes is really, really fast. 60 megabytes, imagine you have to move like 50,000 times 60 megabytes. It's pretty slow. 5 megabytes is so very great. I don't have money. And use layer of Dockerfile wisely. There's a lot of best practices about Dockerfile. Please read it. There are plenty. Just wrote on Google Dockerfile best practices, because you can cache layer and in adding feature to your Dockerfile, so your build will be faster, and sharing and upgrading with a new feature the Dockerfile and the build of Docker would be very easily. The bad of Docker is that on big file he doesn't have good performance. The bad of Docker is that on file system is pretty slow. On big file, there is a big hack that the MongoDB guys apply in order to have good performances with Docker. If you want, please read it. It's a great paper and it's very enjoying to read. So be careful, because on large file you would have some problem. So I'm going to, we have to say which is the perfect orchestration. There is another demo here. Is a slide demo. Do you like this kind of demo? So for me, the perfect orchestration is that you can easily deploy. You can easily roll back. You can visualize, and you can share, commit, merge infrastructure. That's why Docker won on this ecosystem. So this is the perfect orchestration, when the processes respect what you need, but you also have lead time short, the lead time is short, feedback is fast, you can visualize, and the improvement loop is infinite. Don't stop improve. So this is the perfect orchestration, and I have like another 10 things to say, but the time is over. And thank you. So this was a few things that you should know in order to be a better DevOps and also maintain your integrity as developer and enjoy your life. So that's the talk. We have 3 minutes for questions.